Section 8.1, we're going to talk about factoring trinomials and factoring difference of squares. Okay, what does the word factor mean? Well, the word factor you should have seen before sometime in your life. I might ask you to factor the number 24. Factor means to write using multiplication. So 24 I could write as 8 times 3. Or I could write it as 6 times 4. Or I could write it as 12 times 2. There are lots of ways to factor 24. But the most important one is this. I'm going to start with my 12 times 2 here. I could factor the number 12. I could factor the number 12 as 6 times 2. So it's 6 times 2 times 2. And then the number 6 factors as 3 times 2. So I could factor the number 24 as 3 times 2 times 2, which I might write as 3 times 2 cubed. That's called the prime factorization. Okay, 3 and 2 are prime numbers that can't be factored any further. What we're going to look at in this section is not factoring numbers, but rather factoring trinomials and factoring difference of squares, as the title indicates. Now, let me tell you where this is coming from. Back a few sections ago, we did something called multiply polynomials. We did something called FOIL, for example, where I might give you x plus 3 and x minus 5 and ask you to multiply that out. And you would have x squared minus 5x plus 3x minus 15. And then you would combine your like terms, x squared minus 2x minus 15. What's going to happen in this section is we're going to go completely backward. So in this section, we would start with the x squared minus 2x minus 15. And the question would be, what two binomials multiplied together give me x squared minus 2x minus 15? That's what we mean to factor a trinomial. We mean to write it using multiplication, and it will be the multiplication of two binomials. Well, of course, we already know from above that there's the right answer. But the question is, how would you get the right answer if you didn't already know the right answer? Okay, so the best way to do this is to look at some problems, and we'll see what we can do here. Let's say we had t squared plus 9t plus 20. Here's the way I do this. I recognize this is going to factor as two binomials, so I write down a couple sets of parentheses. I have to get, when I do FOIL, I have to get a t squared in the front. Well, there's really only one way to get a t squared. I have to have a t there and a t there. So that when I do FOIL, t times t gives me t squared. Now I look at this number at the end, 20. How can I factor 20? Well, I can factor 20 in quite a few ways. I can factor it as 1 times 20, 2 times 10, 4 times 5. Those are my options. Now what I have to do is look at my options and recognize, all right, 4 times 5 will give me 20. Can I use 4 and 5 to also get the 9 in the middle? And I think I can. I think I want a plus 4 and a plus 5. And then what you do, once you have your binomials written down, you have your guess, you FOIL it out and you check. So here's my check. I would have t squared plus 5t plus 4t plus 20. Yep, there's the right answer. Combine my like terms, I get the 9t in the middle. Okay, let's try a few more of them. How about a squared minus 6a minus 16? Again, I recognize I have a trinomial. So I write down two binomials, a and a, because that's the only way to get a squared. All right, here I've got a 16. How can I get 16? I can use 16 and 1. I can use 8 and 2. I can use 4 and 4. All right, but one thing I need to notice on this problem is that I have a minus 16. So in order to get a minus 16 here, one of my numbers is going to have to be negative, and one of them is going to have to be positive. That's the only way I can get a negative on the end. All right, so once again, I look at my numbers, 16 and 1. If I have a 16 and 1, can I get a negative 6 in the middle? No, I don't think so. 16 and 1, I could get a 15 if I subtract them, or I could get a 17 if I add them. No way to get a negative 6, though. 2 and 8. If I have a 2 and an 8, can I get a negative 6? The answer is yes. I have a negative 8 right there and a positive 2 right there. Negative 8 plus 2 would give me negative 6. I'm not going to do the FOIL and check it this time. You should. FOIL it out, check it, make sure it works. All right, a couple more. How about r squared plus rt minus 20t squared? Okay, right away you should recognize something different with this one. The difference is this one has two variables. It's got r and t. It doesn't change things a whole lot. I write down my two binomials. To have the r squared in front, I'm going to need an r and an r. To have the t squared on the end, I'm going to need a t and a t. So that's really kind of the only change right there. We throw that other letter on the end. All right, once again, I look at my number 20. 20 is 1 times 20, 2 times 10, 4 times 5. Once again, I see that I have a negative 20, which tells me one of these is going to be negative, one of these is going to be positive. Again, I look through my list of numbers. 1 and 20, no way to get there's really a 1 right there. No way to get a 1 out of a 1 and a 20. 2 and 10, can't get a 1 out of that. 4 and 5, there we go. I can get a 1 out of that. To get a 1, I would need a positive 5 and a minus 4. Again, do the FOIL, check it, make sure it works. A couple more problems. A squared minus 8ab plus 12b squared. Again, I recognize that I have two letters. Not a big deal. A and A have to go in the front to get a squared in the beginning. B and B have to go in the end to get b squared on the end. All right, my number here this time is a 12. 12 is 1 times 12, 2 times 6, 3 times 4. All right, but a couple of different things here. I notice I have a plus right here, but I have a minus right there. So what that tells me is that I'm going to have a minus here and a minus there. Because when I multiply two minuses, a minus times a minus will give me this plus right here. But when I add two negatives, a negative plus a negative will give me the minus in the middle. Again, I look at my list of numbers. It's got to be 2 and 6. And again, this one I am going to FOIL out because I just want to show you how these signs work out here. This would give me a squared minus 6ab minus 2ab, and then minus 2 times minus 6 would be plus 12b squared. So notice that these two do give me the negative 8 in the middle. All right, the last thing I want to caution you on about factoring trinomials is not all of them factor. Just like not all numbers factor. If I gave you the number 17, the number 17 doesn't factor. It's a prime number. Same thing with trinomials. Not all trinomials factor. Let me give you one here. How about x squared minus 3x minus 6? And there's no real easy way to look at a trinomial and recognize that it's prime. What you do is you simply test it out. I'd have to have x and x here. Let's see, I recognize that I have a minus right there, so one of them has to be positive, one of them has to be negative. Doesn't matter which one, you can make either one positive, either one negative. And then I look at my number 6 here. 6 is 6 times 1, or it's 2 times 3. But I look at this number in the middle here, a negative 3. If I use a 6 and a 1, there's no way to use a 6 and a 1 to get a negative 3. And there's no way to use a 2 and a 3 to get a negative 3. So my answer is prime. That one doesn't factor. That's going to happen occasionally. It's okay. It's okay if it doesn't factor. You write down prime. All right, the other thing in this section was the difference of squares. And the difference of squares, again, this is something we saw earlier. We saw it when we did multiplication. we had a formula that looked like this. A squared minus b squared is the same as a plus b times a minus b. And the way we used that back a few sections ago is if we had something like 2x plus 5 times 2x minus 5, we noticed that these two things were what we called conjugates. They're the same, 2x5 and 2x and a 5, except one's got a positive and one's got a negative. And we saw what happened. What happened when we did FOIL is the middle two terms canceled out. So we multiplied the first two terms, we got 4x squared, minus, multiplied the last two, we got 25. The middle two terms will cancel out. What we're going to use that for, we're going to use that for factoring binomials. Let's say I have x squared minus 81. What I need to recognize here is I have difference of squares. X is squared, that's obvious. 81 happens to be 9 squared. So I recognize I have square minus square. I have x squared minus 9 squared. That fits exactly into that difference of squares formula. So this factors as x plus 9, x minus 9. So that's pretty much what these problems are. You need to recognize you have a square minus a square. Once you recognize that, you're in good shape. Let's say we had 9x squared minus 49. Once again, I recognize I have square minus square. 9x squared is the same as 3x, whole thing squared, because 3 squared is 9. And my 49 squared here happens to be 7 squared. So I have a square minus a square. Factors as 3x minus 7, 3x plus 7. Now notice this time I put the minus first. Up there I put the minus second. Again, it doesn't matter. It doesn't matter. As long as one of them is negative and one of them has a positive, your answer is correct. The thing to watch out for on these is something like this. Notice this one would be actually a sum of squares because I have a plus in the middle. A sum of squares is always, always, always prime. Okay? A lot of people try to do this, and this is wrong. They try to tell me 25x squared plus 9 is the same as 5x plus 3 times 5x plus 3. But that doesn't work. And remember why it doesn't work. We looked at these a few days ago. You FOIL these out, you get 25x squared plus 15x plus another 15x plus 9. You get 25x squared plus 30x plus 9. Those two middle terms don't go away. They stay there. You get a 30x. Okay, so watch out for that. That's the dangerous one here in this section. If you have a plus in the middle, it's not going to factor.